Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques. In this particular video, we're going to be looking at data tables and how they can manipulate columns in particular in R. So let's go ahead and see what we can learn. So we're going to be focusing primarily on column calculations using data tables in R. So let's go ahead and load our initial package, data.table. And what we're going to do with these 3 lines of code is we're going to load our package in the first line, and then we're going to convert default data sets in R, MT cars and iris, into data.tables. MT cars is going to have data about cars. Iris is going to have data about the size of flowers. And we're going to use these 2 data sets throughout this particular example. And also don't forget that MT cars and iris are by default installed in R Studio, or R in general, excuse me. So now what we're going to do is we're going to run our first little line of code. And so what we have here is we're going to look inside the MT car data set, and we're going to pull all of the cars that do not have the value transmission equals 0, or AM equals 0. So if we look closely at MT cars for a second, we have a variable here called AM. You can see it right here. And there are 1s and 0s in it. So a 1 means it has an automatic transmission. A 0 means it does not. What we're doing here in line 6 of our code is we're asking R, or we're telling R, find all of the cars that do not have a 0 in that particular column for AM. That's what we're looking for. In other words, we're looking for all the cars that have a 1 there, basically. Okay, so we're learning how to use the ideal of not logic. And so now if you look at our output right here, you can see if you look at this column AM, I hope you can see this, you can see they all have 1s. And so that's what we were looking for. We were looking for AM does not equal 0. That's what we were looking for. And so this little exclamation point means not. And of course, equal still means equal. And so again, this is unique syntax to the data.table package. Moving on to our next little trick here. Of course, you can combine several conditions into one statement, if you will. So in this one, we're going to look for when automatic transmission equals 1, or AM equals 1, and when cylinders, the number of cylinders does not equal 6. So, cars often have 4, 6, or 8 cylinders. We're looking for ones that do not equal 6. And so that's what we're doing here. Now, this little ampersand in the middle right here, this is the and when you're using logic type syntax in R Studio, or in R, excuse me. And so now we have 2 conditions. It must have an automatic transmission, and it must not have 6 cylinders. And of course, we're saving it as an object right here, AM_CYL. And so here's our output. So notice how we have in cylinder only values that are 4 and 8 right there. And also notice how we only have in AM values that equal 1. That's exactly what we wanted. And notice also when you want equal, you have to use 2 equal signs in a row. This is different because 1 equal sign is like when you assign a value to an object, and we don't want to assign a value. We want to make sure that what we're looking for meets the value. That's why you use 2 equal signs. All right, moving on. Next, we're going to play with some text. So we're going to go over to our iris data set. So before we do that, let's take a quick peek at it in case you're not familiar with this data set. All right, so here's our iris data set. You can see we have different lengths of sepals. These are parts of a flower, petal, another part of a flower, and then the species name. We're going to focus on this column in particular because of the text. So what we're going to do here is, what are we looking for? Okay, we're going to be subsetting from iris. That's why our little data table is on the outside. We're looking for species that equal setosa. This is our text. And the petal dot length is less than 1.3. That's what we're looking for. And so what's unique this time is our use of text. That's what's new, and that's what we're focusing on. So you can see we have 4 flowers. Notice how they're all are setosa, as we asked, and their petal dot length, that is this column right here, is less than 1.3. And we have 4 flowers and that match that criteria, or that search, if you will. And so again, notice the use of the double equal signs. You have to do that. And you notice how we have to put our text in quotation marks. Moving on to our next trick. Sometimes we can search when we don't know exactly what we're looking for. And so an example of that would be right here. We're looking inside the iris data set again. So that's why it's on the outside of the brackets. Species, and this is our like. This is a phrase or an argument that you often find in SQL, but it won't have the little percentage signs in front of it. This is unique to our syntax or the R language. And so we're looking for species like inside the species column, inside the species column, like when it contains a V. And so in this particular data set, a lot of the different values in the species column have a V. So we're just going to look at the head. We're going to look at the first 5 values that show up rather than pull everything. It could get pretty long. So let's go ahead and do this. And so you can see we get the first 6 values. So versicolor, notice how they all have a V, all have a V. And that is just how we can do that. And of course, now I have to be honest, there's way more than 6 values, but we use the head function on our object, any underscore V, just to save space on the output. That's all. Now, our next one is when we look at just the ending. And so this is a little bit different here. So we're making our object here in underscore flowers. We're using the iris data set. Species, like again, and color. So we're looking for things that end with the phrase color. That's what the little $ indicates for R. It ends with the phrase color. And so again, because there's a whole lot of data that matches that criteria, we're just going to look at the head of the first 6 rows here. So there we go. So notice what we have here. We have all of these in species. They all end with the word color. That's what we are looking for in the species column. And so again, this is how you can search based on text when you're not quite sure what you're looking for. And so if you put the $ at the end, it means that this text should be at the end of the whatever line of code you're looking at, whatever string you're looking at. And when you just put the V here, it just means it kind of starts with the V. That's what it means. So that's important. Now, next one, almost done here. And so let's say you have multiple criteria within one column. So here's our example right here. So here's what we're doing. We're going inside empty cars again. And inside our brackets, we're looking into cylinder column this time. And this time we're using this in, %, and that means look inside this column for these values right here, 4 or 6. So now we're only looking inside one column. When we did examples before, like for example in line 10, notice how we were looking at 2 different columns. Now we're looking within one column. So in our latest example, any car that has 4 or 6 cylinders will be filtered and we will be able to see them. So let's go ahead and take a look at this. And so you can see we got a lot of values here. And if you focus on the cylinder column, you only see, this is the cylinder column right here, you will only see 6s and 4s all the way down. And so this search matches the criteria that we gave R. Now let's wrap this up. We're almost done here. Last one, you can also search for a range within a column. And so we're going to take a look at that as our final example. So here we go. Now we're using empty cars again, and we're looking for miles per gallon, and the values need to be between, and inside here, 20 and 22, So again, this between and this in, this comes from SQL, or it may have been inspired by it, but notice how we put it inside the percentage signs. That's how we make the argument for that. So when we run this code, all we're going to get are cars that have a miles per gallon between 20 and 22. That's what's happening right here. Notice the use of the C function. I haven't been highlighting that, the concatenate function. So let's go ahead and run this as miles per gallon, our MPG underscore 20 underscore 22. And so we have 5 cars that meet this criteria. And if you look closely at the first column, the furthest to the left, you can clearly see that all of these cars that we have displayed here all are between 20 and 22 miles per gallon. And so that is essentially how you can use data.table to manipulate data using a slightly different syntax or an approach from what you might be familiar with dplyr or subsetting data using things from base R. So let's review and wrap this up. So in this video, we were focusing again more on how to manipulate data using data.table, a package that is available. I think it's defaultly installed in R. And so we focused on using not and logic as well. So exclamation point equal means not, as you can see right here. We also learned about and, the ampersand right here. We also learned how you can use arguments that are often associated with SQL. For example, the like. So looking for anything that has a V in it, basically, or ends with the phrase color. We also learned about in, another phrase that is associated with SQL, and between. Notice how these are all captured within percentage signs. Would allow you to either look for anything that matches the criteria to the right of the end, or if you're looking within a range, using the between. So I want to thank you again so much for listening and watching this particular video. My name is Derek Thomas. I am the Director of Educational Research Techniques. Take care.